Hi everyone. In this video, I am going to explain about the carry look-ahead adder, or it's also known as the look-ahead carry adder. In the previous video, I told you how to construct a ripple carry adder, and thereby we have also seen um, parallel binary adder and subtractor. So the main purpose of carry look-ahead adder is to improve the speed of addition operation. When we are using 4-bit parallel adder, 4-bit parallel adder, which is also known as a ripple carry adder, also known as ripple carry adder. When I was discussing the 4-bit parallel adder or ripple carry adder, there I told you the ripple carry adder has more delay compared to remaining adders because the next stages have to wait for the generation of carry from the previous stage. Suppose let us consider a 2-bit parallel adder. Consider a 2-bit parallel adder. So 2-bit parallel adder, we are having two full adders, full adder 2, full adder 1. Two full adders are there. The input carry is connected here. This is input initial carry 0, and here it is A0, B0, first bit, and the second bits A1, B1. Okay. Now the output of this one is connected to the input of next stage. Okay, the output of carry of the first stage is connected to the input of the second stage, and here this is S0, S1, and this is the carry output C2. Okay, this is the just a circuit diagram or a block diagram, logical circuit diagram for the 2-bit parallel adder. This is fine, but what is the problem with this type of network if it is a ripple carry adder? Though the inputs A0, B0, A1, B1 are applying parallelly to those full adders FA1 and FA2, okay, the second full adder has to wait. The second full adder has to wait for the generation of C1 from the first stage, because until the process of FA1 is completed, the carry 1 will not be generated. Carry 1 is generated only if and only if the full adder 1 has performed its operation with the inputs A0, B0 and Cin. Okay. FA2, full adder 2 has to wait until the generation of C1. Once the first operation is completed, then the full adder 2 will take place and then its operation is completed. Suppose if 1 nanosecond is the time delay for this full adder 1 has to accomplish, and this is also 1 nanosecond, then total time delay taken by this ripple carry adder for the 2-bit adder is 2 nanoseconds, because and it has to the second full adder has to wait for the carry generation from the previous stage. Okay, total time delay is 2 nanoseconds. Within 1 nanosecond this will not happen because both are not running parallelly. Though the name is parallel adder, they will not run parallelly. It is a serial action. Okay, first full adder first it has to complete the operation, next full adder has to done later. Okay, so to avoid this, we are using a method called carry look ahead adder, or also known as look ahead carry generator. If you see the name look ahead carry generator or look ahead carry adder, so it is the name, the meaning of this name is the carry is generated priorly whenever the inputs are given. Whenever the inputs are given A0, B0, A1, B1, such that we are having 4-bit adder, 4 A0, A1, A2, A3, B0, B1, B2, B3, whenever all these address are available, then only the carries are generated. Okay, that is the main purpose of carry look ahead adder. Immediately at the in the beginning itself, in the starting stage itself, it generates the carries, so that it is no need to depend on the previous stage. Okay, see, whenever we are having a naught b naught, a1 b1, and initial carry cn, when these 5 bits are available at the at that stage itself, if we generate the carry 1, carry 2, carry 3, and so on, all the carries, which how many number of stages are there, that many number of carries are generated, then all these full adders can run parallelly. Okay, so this is the meaning look ahead generation of the carry, so that the adder which is made up of this particular look ahead carry generator is known as look ahead carry adder. Okay, so the construction is originated from the full adder with the two half adders. So let us consider full adder with two half adders, full adder with two half adders. So this is the first half adder. Output is carry and sum. This is second full adder, second half adder with some input. First output of this sum is connected as the input for the second half adder. This is the carry input Cn, An, and Bn. We are taking nth stage. The output carries are added. Sorry, not added. They are all together. This is An, Bn. It is represented as Gn. This is known as carry generator. Carry generate, carry generate, carry propagate. This is An XOR Bn, that is known as Pn. This is known as carry propagate. Carry generate and carry propagate. These two are the important parameters in the generation of the next coming carries. Okay, and this is carry and this is sum. So sum directly we can calculate, which is nothing but An XOR Bn XOR Cn and it is Cn into Pn. Cn into Pn. This is AND operation. And these two are odd together. So it is Cn Pn plus Gn. Okay. So therefore the carry output is expressed as Cn Pn plus Gn. Substitute what is Pn here. Pn is nothing but An XOR Bn. So Gn plus An XOR Bn into Cn. In the similar way, what is Gn? Gn is nothing but An Bn. So An Bn plus An XOR Bn into Cn. This is the output carry. This is the sum An XOR Bn XOR Cn. Okay. So we are going to calculate the next stages based on next stage carries based on the final stages carries. Like, so for the final sum and carry, for the final sum and carry of the nth stage we get the following. We get the following Boolean expressions. These Boolean expressions are important in the calculation of the coming carries. So sum is equal to carry propagate XOR Cn, where Pn is equal to An XOR Bn, and C out is equal to, which is nothing but also known as Cn plus 1, because Cn is the initial carry we have taken and the Cn plus 1 is the next stage carry, that is equal to Gn plus Pn Cn, Pn Cn, where Gn is equal to An Bn. Okay, so based on those two equations, we are going to write the carry expressions for all the n number of stages. Based on these expressions, the expression for the carry out, the expression for the carry outs of various full adders, are shown here. So first one, C1. How to calculate C1? C1 is nothing but n is equal to 0. Cn plus 1 is expressed as Gn plus Pn Cn. Okay, so when you are taking n is equal to 0, that means it is C1. C1 is equal to G0 plus P0 C0. G0 plus P0 C0. Okay, what is G0? G0 can be calculated as A0 into B0. G0 can be calculated as A0 into B0. And similarly C2. How to find C2? C2 is obtained by taking n is equal to 1. When n is equal to 1, it is G1 plus P1 C1. G1 plus P1 C1. What is C1? Substitute C1 what we have got in the previous stage. So G1 plus P1 into G0 plus P0 C0. So that is equal to G1 plus P1 G0 plus P1 P0 C0. This is C2. Okay, and C3 is equal to, so similarly C3 can be obtained by taking n is equal to 2. So G2 plus P2 C2. G2 plus P2 C2. What is C2? Substitute that C2. P2 into G1 plus P1 G0 plus P1 P0 C0. So if you multiply that, G2 plus P2 G1 plus P1 G0, P2 P1 G0 plus P2 P1 P0 and C0. This is the expression for C3. Similarly, can you write C4? And C4 is equal to G3 plus P3 C3. Again, G3 plus P3 into, what is C3? G2 plus P2 G1 plus P2 P1 G0 plus P2 P1 P0 C0. So G3 plus P3 G2 plus P3 G2 G1 plus P3 P2 P1 G0 plus P3 P2 P1 P0 and last one C0. This is C4. So if you observe all these four equations, suppose take first equation C1. Okay, C1 is the carry generated from the first full adder stage. That is obtained by knowing, see what is G1, what is G A into B, what is P A XOR B. Okay, so A, B values are sufficient here and initial carry is sufficient to generate the C1. And similarly, C2 is also obtained with the same terms. See properly. G is nothing but it may be AND operation between A and B, and P is nothing but XOR operation between A and B. Okay, these two are obtained, that is fine. And G naught, P naught, these two are also with the A and B's and initial carry. And here also we are having C3. C3 is also obtained from the carry propagate and carry generate along with the initial carry. And C4 is also same. That means if you know the AB values and initial carry, that is sufficient to find any type of carry at any stage without using the full address. Okay, so if we are able to calculate these particular carries at the initial stage itself, then we no need to wait for the carries from the previous stages, so that all address can be run parallelly. Okay, so in general we can write for carry n, in general we can write Cn is equal to Gn minus 1 plus Pn minus 1 Cn minus 1, that is equal to Gn minus 1 plus Pn minus 1 Gn minus 2 plus Pn minus 1 Pn minus 2 Gn minus 3 plus and so on plus Pn minus 1 P naught C naught. So Pn minus 1 to P naught, Pn minus 1 and minus 2 and so on, P2, P1, P naught 2 into C naught. Okay, that means initial. So by seeing the carry expression, by seeing the carry expression, we can understand that the initial carry is sufficient to find the next stage carries. Next stage is carry with the help of carry generate and carry propagate and carry propagate. Okay, so carry propagate is represented as P, carry generated is represented as G. Okay, so let us draw the look ahead carry generator logic diagram. So this is look ahead carry generator, look ahead carry adder or generator. So in order to generate carry propagate and carry generate, we should use one half adder. XOR gate followed by AND gate. Simply these two represents half adder. So this is first half adder set. Second one, Okay, so it is A not A1. Okay, initially we are having carry also, so this carry is given here, that is C1. Okay, C1, here it is A4, B4, A3, B3, A2, B2, A1, B1. Or you can also represent from the 0 to 3, A0, B0 to A3, B3, we can represent. And all these are carry, generate and carry propagate. This is propagate, this is generate. Propagate, generate, propagate, generate, and P1, G1. Carry, generate and carry propagate. Now, automatically whenever we are giving this carry, generate and propagate, carry propagate with initial values, so the manipulation gives you the carries. Next carries, let it be C5, C4, C2. These are the carries. So here first carry we have some S1. So for this S1 we need input carry and P1. Again we have one more XOR gate. So S2, P2, C2. One more XOR gate, P3, C4. And next P3, C3. Next we have C4, C4, so S1, S2, this is S3, this is S4, and here it is P4. So C5 is free, C5. Okay, so this is the design of carry look ahead adder based on the carry generate and carry propagate expressions. Okay, G is carry generate, P is carry propagate. Okay, thank you.